All right, today we're going to be spending a little bit more time looking at the specifics of quadratic equations. What you're going to see is it's going to look very much the same as the type of problems that we did yesterday. We're going to be provided with some points, some tables about a particular parabola, and then we're going to talk about the equations. The only difference is today we are going to be actually determining the exact equation rather than just the format of it, which is like what we did yesterday. Okay, so today we'll look at determining exact quadratic equations based upon points from the graph. And you should recognize these points. Okay, this is the example that we started off yesterday. Okay, but as I said, only this time we're not going to be just selecting the format of the equation. We're going to be looking at the exact equation. And in order to do that, today we're going to have to figure out how to come up with this value a, this coefficient in front of the independent variable, and also this value c, okay, that represents the vertical shift. Okay, and those are the values that we're going to be working on figuring out today. Okay, so back to yesterday, same skills that we were working on yesterday, same questions as yesterday, just going to have slightly different answers this go round. Okay, so have a look at these points. Okay, as far as a parabola goes, is there a vertical shift to this parabola? Okay, there is no vertical shift. Okay, why is there no vertical shift? How can you tell that? Okay. So this one has not been moved because it does pass through the origin. We can see that right there. That's what the parent function is supposed to do. Okay, so there is no vertical shift. Okay, what that means to us today is that our equation, okay, as we saw yesterday, our equation will not need a c value. Okay, so that much, at least on this step for this problem, remains the same as yesterday. We will not need an equation that has plus or minus anything hanging on to the end of it. Okay, that's important. If we had decided that a vertical shift was present, then we would have plus or minus some number other than 0 right there. And we'll get to an example like that here in a moment. Okay, the next thing that we looked at yesterday will be the same thing we're going to look at today. Let's see if it has been stretched or compressed in any way. Okay, well, remember how we checked this yesterday? We identified our line of symmetry, okay, right through there, and we know that this is the line of symmetry because we can look on either direction away from the line of symmetry, and it's doing the exact same thing, going upwards and going downwards. We can see that in the y column. Okay. Now, the thing is, as we change 1 unit in the x direction away from the line of symmetry, according to the parent function, that ought to change 1 unit squared in the y direction. Okay, so we're expecting on the y side, it ought to go up either direction 1 squared, which would be 1. Okay, but look at how big the step is. It went from 0 to 2. That's not 1 step, that's 2 steps. So as we changed 1 on the x-axis, we changed 2 on the y-axis. Okay, we can check this again. If we move away from the line of symmetry 2 steps on the x-axis, okay, well, according to the parent function, that ought to, on the y-axis, be 2 squared steps, which would be 4. Okay, so it should be 4 steps on the y-axis, and if we look at what's actually happening in our graph from 0 to 8 would be 8 steps instead of 4. Okay, so it ought to be pretty clear that this graph is not following what the parent function says it ought to do. So has it been compressed or stretched? Yes, it has. Okay, it is not obeying the y equals x squared parent function. Okay, but the question is now, okay, is it actually compressed or is it actually stretched? We're going to need to know because it's going to change the number that goes in front of x squared. Okay, well, let's have a look. We expected, as we changed by 1 unit on the x-axis, we expected it to change 1 squared unit on the y-axis. Okay, and it actually changed 2 units. So it took a bigger step than we expected it to. On this second step that we took away from the x-axis, we expected that to change 2 squared would be 4 steps. It actually changed 8. So again, it took a bigger step than we expected it to. So would that suggest that a graph has been compressed, squished down, or has it been stretched, gotten bigger? Well, it's taking bigger steps than we expected it to. That is stretched. It's been pulled more vertically than it wanted to be. Okay, so has it been stretched or has it been compressed? It's actually been stretched. Okay, so that's an important thing for us to recognize today. And the next thing, okay, the next question that's going to lead us to is by what factor did it get compressed or what factor did it get stretched? Okay, well, what were the steps doing, okay, compared to what we expected them to do? We expected a 1 right there. We expected a 4 right there. Compare the numbers that we got to the numbers we were expecting. What's the difference between 1 and a 2? Well, the 2's double, isn't it? Okay. What's the difference between 4 and the 8? Again, double. Okay. So we're getting numbers that are twice as big as we were expecting. That is a factor. The factor is everything is happening times 2 compared to what we were expecting to happen. Okay. That value that you just figured out there, that times 2, that is going to be your coefficient for your independent variable. That's our a. So in this particular case, no vertical shift, our coefficient for x squared is going to be 2. Our equation is y equals 2x squared. And then we actually don't even need the plus 0 because plus 0 doesn't change anything. But that's kind of what we discovered with our vertical shift, is that there wasn't going to be one. So our equation, probably most specifically, is y equals 2x squared right there. Okay, that's what we're going to be doing today. We're going to be figuring out how to get the actual numbers that belong in the equation. Now, I realize that's probably a little confusing to a lot of folks. We're going to look at several examples. Okay, so let's look at another one. Here's another parabola, and we're provided with these points. It's going to be the same little series of questions each and every time. Okay, same questions that I ask myself. These are going to be the same questions you ask yourself in order to get these equations. What would be the exact equation of the parabola? We're going to have to answer, is there a vertical shift? If there is, how much is it and in which direction is it? Okay, has the graph been stretched or compressed? If it has been, then by what factor has it been stretched or compressed? And based upon the answers to these two equations, we will very easily be able to build an equation. Okay, so let's have a look here. First question, is there a vertical shift? We'll have a look at the points. Is there a vertical shift or not? Okay. This graph does have a vertical shift, and it has a vertical shift because it does not pass through the origin like it was supposed to. Okay, so is there a vertical shift? Yes, there is. If so, which there is, how much is it? Okay, how far did this graph miss the origin by? Missed it by 4 units, right? Okay. Did it miss it by 4 units above, like a positive 4? Did it miss it by 4 units below? It missed by below, okay? So it's actually a negative 4 vertical shift because it got moved downward. Okay, so let's move on. Next question. Has it been stretched or compressed? I don't know. Let's have a look. We've already figured out where our line of symmetry is. It's right there. Okay, so let's start making some steps. As we step 1 unit on the x-axis, either direction, the parent function would tell us that it is supposed to move 1 squared units in the y direction. That would be a 1. Let's see what we did get. From -4 to -3, how much of a difference is there from -4 to -3? Only 1 unit. Okay, so that looks good. All right, as we take bigger step, 2 steps, okay, the parent function would say that we should move 2 squared, which would be 4. Let's see how much we did move. From -4 to 0, how much of a difference is that on the number line? That's 4 units. Okay, this is looking like it hasn't been compressed or stretched. We have some extra information in the chart. We can even check this one out. 3 steps on the x-axis should be 3 squared steps on the y-axis. That would be 9. How much of a difference is there between -4 and +5? Well, that is 9. Okay, so this one, it is following what the parent function tells it should be following. Okay, so this one doesn't have any stretch or compression to it at all. So what we just discovered is this. There is a C value. It's -4. There is not any change in the A value. What's the A value supposed to be? Okay. How many x squareds do we have in the parent function? Y equals x squared. There's just 1. Okay, so if there's no change, then our equation is y equals 1 x squared. And there's that vertical shift that we discovered, -4. That is the exact equation that will bring us a parabola that contains these points. Okay, let's look at another one. Oh, we got fractions in there. Got a bunch of points, got some fractions in there. You know what fractions change when it comes down to a graph? Nothing. Yeah, it just means we got points that aren't sitting on whole numbers. It's no big deal. Okay, same problem as before. If a parabola had the following points on it, what would be the exact equation of the parabola? Well, the same questions are going to exist every single time. Is there a vertical shift? And if so, how much was it? In which direction did it go, positive or negative? Has it been stretched or compressed? And if it has, by what factor? And that should bring us all the information that we need in order to answer or write an equation. Okay, well, let's have a look at this thing first. Is there a vertical shift? Have a look at the points. Has it been shifted? Okay. The graph is not passing through the origin like it's supposed to. Okay. Okay, so there must be a vertical shift there. So is there a shift? Yes. If so, how much is it? Well, how much is the shift this time? 2, positive or negative? It is positive this time. Okay, it's higher up than it's supposed to be. So we got a +2 shift. Okay. Next question. Has the graph been stretched or compressed? I don't know. Let's have a look. Okay, here's your line of symmetry. All right, as we move 1 unit either direction on the x-axis, we should move 1 squared units on the y-axis. Ooh, look, from 2 to 1, 2 1/4. Now, what's the difference between 2 and 2 1/4? It's only 1/4 of a step. It was supposed to move an entire step. Clearly it didn't. Okay, let's look and see what else we got. As we move 2 steps, then we should move 2 squared steps, which would be 4. We actually move from 2 to 3, which was a single step. And we could continue this on if we wanted to see what else is happening. As we move 3 steps on the x-axis, we should move 3 squared steps on the y-axis. That would be 9. And we actually only move from 2 to 4 and a fourth. That's 2 and 1/4. Or if we wanted to keep it in terms of fractions, that would be 9/4. Okay, so it seems very clear, okay, that it has been stretched or compressed. Okay, now the question is which one? Is it taking as big a steps as it's supposed to, or is it taking smaller, or is it taking bigger? Yeah, it's taking small steps. Okay, so this time this graph has been squished. Okay, it's being compressed. Okay, now we need to figure out by what factor. Well, all you have to do to answer that is figure out how big the step was supposed to be, and then look at the size of the step that it actually was. Okay, like on these red guys here, when we took one full step on the x-axis, we expected one full step on the y-axis. We only got a fourth. Okay, that's actually pretty easy language right there. We got a fourth of what we expected. Okay, same thing. Let's look at these 2's. Okay, when we took 2 steps on the x-axis, we expected 2 squared, which would have been 4. We expected 4 steps on the y-axis. We only got 1. So once again, we got a fourth of what we actually expected. And you could even continue that with the 3 steps there. Okay, 3 steps on the x-axis would have been 9 steps on the y-axis. We didn't get 9. We got 9/4. So once again, we got a fourth, and it happens on everything. We're getting a fourth of what we're expecting every single time we look at the steps. So what is the scale? What is the factor? It's a fourth. Okay, we are getting a fourth of what we should have every single time we look at the values. Okay. Well, there are your 2 numbers. Here is your C, okay, this 2. That's your C, your vertical shift. That's your A, okay, your coefficient in front of your independent variable. That's our equation. Y equals 1/4 x squared plus 2. Now, it can be a little harder to see, okay, what the factor should be on a compression, because you do tend to end up with fractions, okay, which makes sense. In order to compress a parabola, the number has to get smaller than 1. The coefficient has to get smaller than 1. So if it's compressed, you're always going to end up with a fraction here. If it's stretched, most of the time you're going to end up with a whole number bigger than 1. Sometimes it can be a fraction, a mixed number, usually. Okay. But anyway, so there's an example of one that's compressed. Okay. Here is one last example. I'm going to give you these points, and I'm going to give you a couple of moments. I want you to scribble down these points, and I want you to run yourself through the same questions that I've been running you through. Okay. Is there a vertical shift? If so, how much is it? In what direction? Is it stretched or compressed? And if so, what is the factor that goes along with that? And let's see if we can't build an equation. So I'll give you a couple of minutes head start, and then I will catch up to you, and we'll see if we get to the same answers. The first thing we would look for is a vertical shift. It's very clear that the parabola does not pass through the origin. It missed it by 6 steps, and it was too low. So our equation is going to have -6 attached to the end of it. Next, I'm going to check it to see if it has been stretched or compressed in any way. pretty clear that we're not getting the values that the parent function would like to have. And it's pretty clear that we are getting bigger values than we should, so we have a stretch of some kind. The only question is to figure out how much the stretch is different so we can fill in the rest of our equation. On these values over here, we expected 1 squared, 2 squared, and 3 squared. That would be 1, 4, and 9. We got 3, 12, and 27. Okay. Well, comparing 1, 4, and 9 to 3, 12, and 27, what you're going to find is that all of these are 3 times bigger than they should have been. That means we have a stretch factor of 3. The equation you should have arrived at is y equals 3x squared minus 6. All right, well, this is the way these equations work. If you are handed a pile of points and you know that they are on a parabola, well, you don't even have to know that they're on a parabola. You can graph them, see that they form the shape of a parabola. From there, we can build the exact equation of any parabola without having use of the equation ourselves, without having the calculators. It's really not that complicated. Okay, so there's an assignment that goes along with this. So if you would please have a look at those questions, and that's all.